Hey guys, welcome back again. I hope you are doing well. And again, sorry for late. I was traveling in morning. So let's start today's questions. Let's go always with the lead code first. Okay. Seems like a hard problem. Okay, it is loading. All right. So what is this question? Block placement queries. There exists an infinite number line. Okay, with its origin at zero and extending towards the positive x axis. Okay, it starts from the zero and extending towards positive axis. Okay, x axis. Now we have 2D array queries which contains two types of queries. First, something it looks like this: build an obstacle at distance x from the origin. Okay, it is guaranteed that there is no obstacle at the distance x when the query is asked. Okay, for sure. Now, what is type 2? Check if it's possible to place a block of size SZ anywhere in the range 0 to x on the line such that the block block entirely lies in the range 0 to x. A block cannot be placed if it intersects with any obstacle, but it may touch it. Okay. Note that you do not actually place the block. Queries are separate. Return the Boolean result array for this particular, queries. Now let's see uh, for query 0. Okay, we have these queries, right? So this is the first type. What happened? Okay, this is the first step, and then this is the second. This is the second, and this is second. Okay, right. So first query is uh, 1 comma 2, meaning that where is this? Build the an obstacle at distance x from the origin. So at distance 2, we put the obstacle. Okay. Now the next query 2, 3, 3, meaning size of 3. I guess where is this? Okay. Size of 3 in range 0 to 3. So we cannot size of 3 in 0 to 3 because there is 2 in between, right? So this for second we have uh size of 1 for 1 to 3, in between. So size of 1, 0 to 1. Okay. Uh okay. 0 to 1. So we can put, right, in 0 to 1 there is no obstacle, right? And we have this again size of 2 in 0 to 2. Let's see what happened. For query 0, we place at x is equal to 0, a block of size 2 at most can be placed before x of 3. Okay. Okay. size at most 2 can be best before the size of 2. So the query 2 is not asking to put the obstacle. It's asking just can we put, I guess. Okay. Do not actually place, right? Do not you are not actually placing. So that is why we have true for these two queries. Okay, because we are not actually putting it. So okay, now I get things. The brute force approach would be just get the query, and you know uh we we have to get the size, right. uh the size, and the size, we just need to check that for this particular uh in from origin to that particular range, there should be no obstacle. That's simple it wants. Okay, so let's try. The Okay. So it's already mentioned that the query, the type 1, no obstacle exists at distance x when the query is asked. Yeah, it's already there. So what I'm thinking is just get a query, and if it's asking to put obstacle, just put it. And then again, for type 2, just check that this, whatever the range, whatever the size is, uh, whatever it, this size, uh, you know, let me check this second query again. Uh, Check if it possible to place a block of size SZ anywhere in the range 0 to X. Okay, anywhere. It says anywhere in 0 to X. So we need a particular slot of this range. Anywhere in the, anywhere from 0 to X, this S of size Z. So how we can check that? Okay. So we can check from 0 itself, since it's asking. Okay. So we can, as a brute force, we can start from 0, and then, check the S of Z uh, can be put if we start from 0 range. Okay. And again, if not, then just we can check further after the block. Okay. Something like that. So what I'm thinking is, let's say we have the positive line. Okay. Now for every query, we have either type 1 and type 2, right? One we can put obstacle, other is check in range. Okay. So let's say this started from 0, and we put obstacle somewhere here at 2. And if the query is like, type 2, and this goes for range 10 and asking for 3, size 3. So when we start from 0, okay, so if we are starting from 0, then we just need to do, whatever the particular sz is. This is sz, right? So if sz is lesser than this particular obstacle, okay, not like that, but let's say this is sz, right? Size 3. So it's overlapping this particular obstacle. Okay, so we need to find out a sort of a function. Okay, let's say there is a function I don't know how we are going to implement, but just assume that there is a function. When we pass this particular sz into it with the range this particular, it will uh, gives yes or no. Okay, okay, yes or no. So that's actually this is what we want, right? So this is the core part, that how we are going to implement this. But let's try to reduce the work head, the overload of this function. Okay, just try to make something easier that this function, we are able to implement properly. For example, we if we pass range to this function, that's for this function, then it would be easy to check in particular range can we put or not. Okay, even though we have range already 0 to this particular 10. So so let's say this is the range 0, 1, 2, 3, 4, 5, 6, and we have size 3. So either we can put this, add this, or add this, similar, add this, and so on. Okay, what's if obstacle is here, let's say. So so actually we need to check just in this particular range, where are the obstacles. Okay, and okay, if from 0 to obstacle first, let's say we have obstacle in the sorted order, and if we can put the sz into it, then we can directly return yes. If not, then check in the other range, like this obstacle to other obstacle. Okay, but make sure that this other obstacle, whatever the obstacles, uh, should come in this particular range given. Okay, that is what we need, right? So now this problems comes down to how uh, how we can uh, put things so that it would be easy for this particular function to check it, that we can you know we can just check, we can put this particular block sz in the axis. Let's say we have an array, okay, which is which shows obstacles on x-axis. These are sorted. So if these are sorted, then we have obstacles in our uh, okay, in our this particular axis. So just get first obstacle. Okay, since this particular range starts from 0 to this, right? So get first obstacle and check, you know uh, with 0 to that first obstacle. This 0 will be our previous, let's say the previous. Just assume this is we are storing this let's say something like start 0, and this obstacle will be end. So can we put this, if no, then this obstacle will be our start, and next obstacle, whoever is minimum obstacle, or this range given below, this minimum among these will be our end. And check can we put our sz into it. If yes, then return yes, otherwise no. Again, we can check from the next obstacle to minimum of this particular. Okay, and how much it takes the time. So so probably how many obstacles we have in that, and that is the time it takes, right? So let's try to implement this first, then we can optimize, right? So okay, let's have the array, the list of integer, which is our factors. Okay, new array list. Now we have queries, right? So for in query from queries, and what we can do, we can extract things, from the type. If let's say type, and the type is a query of 0, right? If type is equal to 1, so meaning that we need to insert, right? Otherwise we have to check. This is where we need to check, and this is where we need to put obstacle, right? So for putting, let's say there is a function, uh, you know void insert stack. Okay, and we can have, so on X we need to insert, right? This is X from origin. So let's put this X. We have lower, since we need to put in the sorted fashion, right? So in low, high is equal to the obstacle. We have to pass this also. So we need to put the obstacle dot size minus one. While low is less than or equal to high, we can have mid, uh, low plus high. If uh, obstacles dot get mid is less than X, let's say, less than e, yeah, less than X, then we can go for low is equal to mid plus 1. Else we need to go for high is equal to mid minus 1. Okay, we can have low less than equal to, less than, what happened? Low should be greater than high. Then we can have the answer, the obstacles dot at low of X. Okay. So let's see if there are 1, 2, 3, and we try to put 4, meaning we have to go for one more. Okay. So if this works properly, then we can just insert the obstacle into this X and obstacles. Okay. Now else we need to check. Then we can have a function like also we need result, right? The list type boolean result new, and we can have the result at last. So here we have to check if can what was the second title is possible. Let's say is possible, and we can pass uh, this query, right? But we have x and size. We can get x from query of 0. So I just put it like this: queries of 0, queries of 1. So if it gives true, then result dot add. We can directly think like result dot add. Okay. So we are just trying to add our into the our results possible or not. So this is main function is possible. So first we need x, then s z, right? Again we need obstacles also. So we need to find the obstacles also. Hmm. Now we have x, z, and obstacles. So first, we need to find how many obstacles are in this particular range. This x, right? This is from like 0 to x range in which we are trying to fit this particular sz, right? Trying to put. Uh, we are not actually putting it, just checking can we put or not. Okay. So 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 how block sz anywhere in the range. This particular block, how anywhere in the range. So if we somehow able to get the obstacle, the uh, obstacle that are in the range x, okay. So we have to check uh, with that obstacle itself, right? So let's see for in obstacle from obstacles, and initially our start will be 0 and end will be this particular obstacle, let's say. Okay. Math dot min this particular obstacle we can optimize later, but we need to find uh, the first answer, right? So that's the minimum of the among these two, and and this is our end, right? So okay, we can check then if start end minus start is less than equal to SZ, when return true if yes. But if we go on the you know, if this is not possible, then we have to check that if and is this x is uh, greater than this particular obstacle, let's say, then we have to put start as this particular obstacle, and and otherwise we can break it and then return false. Okay, we have to optimize this particular function at the end, right? This is taking big of n time. So let's see what is this particular thing gets a result return. Okay, we have to go like this step. Now it's giving true. Okay, for everything it's returning true. It's possible. Okay, let's see for this one. We have a query from 2 to, you know, in range 3. Can we put 3? So the answer should be false because in between 3 is there. So when we try to get our first obstacle, okay, so we need to print our obstacles. Okay, we are having obstacle at 1, meaning, okay, we are trying to put uh, at low x. Okay, here it should be but not area of 0. Now what? Okay, we have obstacle at 2, and this is the start will be our 0, and then the end will be 2, and end minus start. Okay, this should be greater than answer. And start plus 1 should be, actually we are not going with the 0, 1, 2, 3. Okay, 4 minus 2 is 2. 0 minus 2 is 2. Okay, now what? For the second, 3 1, right? And we put 1. So again we have start 0, and then end will be like 2, right? This first obstacle is at 2. So the minimum will be 2. Then 2 minus 0 is 2. Is it greater than equal to s there, which is 1? So yes, it is. Okay, we have to go for like and minus star. Okay, I need to think. So we have end 2 for this particular and start 0. So the answer is 2. Again, we need the S thread. S thread. SZ is 3. Yes, for this one, it should be 0 for sure because where is this? Okay, the start 0 and first obstacle is at 2, and yes, that is why it fails. Then we put end at 2 is greater than obstacle. Okay, what was the x for this particular, which is 3? So actually we need to put 1 here and 2 here. Okay, we mistakenly. It's working. Now, uh, let's try for this one. Is this works or not? And then we can optimize. What is this? Type 2, 1, 1. Okay. So, okay, great. This particular test case, meaning that there is no obstacle, and still we are trying to, we are everything doing with the obstacle itself, right? So the first case here, now I understood as a edge case. Okay, if no obstacles, okay, for this particular case, I will do like if obstacles dot size is equal to 0, let's say, then return true always. Now the second case that I am getting is, let's say if there is obstacle at 1, we have range which is far more than that. Okay, and then what? We fail here, right? Since we have obstacle at 1, but we are not able to check from 1 to, let's say, x. Suppose x is 9. From 1 to 9, we are not checking it, right? So in that case, we have to check that this particular does in this middle part. Okay, meaning that uh, can we place uh, this particular block from for the last obstacle? Okay, and before I guess doing this, we have to get the last obstacle itself and check the outer boundary. Outer boundary. Okay, from last obstacle to the range. Okay, which is, let's say, last obstacle to x. Can we fit this particular? Uh, and then we can check this this middle part, meaning that we are checking from 0 to last obstacle. That is what we are doing here, right? So let's see, get the last obstacle, meaning uh, you know in last obstacle, which will be like, where is this obstacles? How to get obstacles? Dot size -1. If last obstacle, and if last last obstacle, is lesser than equal to x, let's say, or lesser than x, or you can say lesser than equal to x, then you can check it. Okay, uh, let's find out the difference. Last obstacle, x minus last obstacle. Okay, and if the difference is greater than equal to sz, let's say. Okay, so it should be this sz, then we can return to. Otherwise, we have to check this particular scene, and this is nothing but the this is nothing but the differences, right? This particular is nothing but the difference. So we have this test. Now let's see, it's passing. So let's try. Now what? Uh, the range 1 and the size 2. For I this particular case, I thought that they will give the valid uh, entry. Okay. Again, we have to check itself first that if x is uh, you know s self is greater than the x, then return false. Okay. Now next what? Okay. Now we have time limit exceeded. Now how we can improve this particular function? Okay. How we can improve it now? For particular range, we just need to know, can is there someone, or uh, how basically we need to optimize this is possible. We check outer boundary, or we are checking inner boundaries. So so Okay, we are putting in our boundaries and then mm, how we can improve this thing. There are only six cases left. So we need what actually we need uh, is it possible to put a particular block, right? So if we somehow able to get that whatever the largest space between the in between origin, whatever the largest space, we able to get that first to check, then we are not we are not going to do this particular route. Okay, meaning that we are uh, you know avoiding this particular time. So how we can get the maximum space between any you know between two obstacle, or from starting to an obstacle, from ending to an obstacle. So we need that particular thing. So that how we can get. Okay, so how this is what it shows, only the obstacles, right? uh, how we can get. Now let me think more. Mm, actually, if we somehow able to find out that the maximum difference between two obstacles, okay, then it would be easy for us to check the can we put that block between two obstacles. The first case is the we are trying to put the block from 0 to first obstacle, and the second from last obstacle to the remaining space, and then can we put that particular block in between obstacle. If we are trying, if we try somehow that get the space, uh, maximum space between any two obstacles, then it would be easy for us, right? So whenever we try to put the obstacle, okay, we have to get the maximum difference. Okay, how we can get that? So this particular function is trying to put the obstacle, right? So we can we can directly get, like, if we are adding this, then if this is, we have the size, I guess, let's say greater than 2, then we can check the previous obstacle, and then the next obstacle, whatever what's the size, you know that will take again time extra. So actually, what we need is, where is pen? Okay. Now what we need, we have number line. When we try to put an obstacle into it, okay, then we have to get, let's say, these conditions that we are checking before and after obstacle stuff. But let's say we put next obstacle here. Then we have to get this max space between two obstacles. Okay. Then we try again one another. Then we check maximum space, which is this much only. Let's say this is maximum space we got. Now, how we can do this particular thing? Let me think. So one thing that coming into my mind is PQ, which will give the preference, right? So, but how we are going to implement this PQ? Hmm, let me think again. This is number line, and we are putting obstacles into it. From any obstacle, we need maximum space, but okay, and let me check the time complexity. 10 to the power 4 and 10 to the power 8. Okay. So while putting, we can check for every, which will take like 10 to the power 8 time complexity, 15 into 15 into, which is obviously greater. We how we can reduce it? The dynamic changes that we need. How to improve? We need the system which always gives us the maximum space between two obstacles. But the obstacles are dynamic, right? They are coming and we need to update it. So it's been a while that uh, you know, I do not have this good, uh, good knowledge of segment really. Okay, probably the segment tree might work here. Okay, but it's been a while since I code for segment tree or even have a knowledge of it. So how? Okay, I guess we need a little break here. We can go for GFG first, and then we come to this part later. Okay, then probably we'll have some sort of we get the insights later on. So what is this? Uh, Replace with XOR or adjacent meaning. You have array of n integers, modify the array in place such that each element is replaced with XOR of its adjacent element. 2 comma 1, 2 XOR 1, 3, 3 XOR 4, 4, 0 to 1, and 0 to 2. Why 0 to 2? For index 1. Okay, for index 0, only one adjacent, which is 1. For index 1, there are two adjacents, 0 and 2. And okay, and we still, you know, for array of 0, we are using the previous value, which is not updated. Okay. Okay. So again, it's saying that in a place such that elements is replaced with XOR of its adjacent. Um, okay. One thing I'm getting is so let's say, and uh, if I zero organic function with that. First, uh, the value, the replacement function, which will be if I minus 1 is greater than equal to 0. If yes, then here are I minus 1. Otherwise 0. And XOR if I plus 1 is less than, where it goes. I plus 1 is less than. Here are dot 10. Then here are I plus 1. Okay. I plus 1. Otherwise 0. And we have this, right? Let me see. For array of 0, no adjacent, that is why in the number itself. For n minus 1, there is only one adjacent. Uh, that is why the number itself. Okay. So we need, instead of 0, array of I, and we have array of I. This is what we get after this particular thing. We can solve this here or later. Uh, we store this result into the result, and we go for the next value. Then it will add, it will calculate the result of that particular value. Then it calls next. Every value calculates the result of it. Later on, we'll try to put the result to this particular index. Okay, and this is in place. And then we can have the start with 0. Let's see how it works. So it's working. That's working. Okay, it's working. But we are using the recursive space, right? But now again, how we can solve this particular question? Uh, this is this is little bit confusing. Okay. Now what we need the maximum space between any two obstacles. So how we can get it? Okay, let's try to get help. Uh, let's use perplexity. Yeah. And let's try to ask him about his code. Time and using way to calculate max difference between stack. Something like this. Let's see what happens. So in this particular question, we have learning. Okay. Once I start call learning, then the perplexity responses. What happened? I guess net problem. Net, net चला लेगा. Okay, let's try to connect on that. Okay, let's that. Okay, currently, yes, we have n square. We need to optimize between consecutive. How to calculate max difference between obstacles? For obstacle position I, we have sorted from origin to first between consecutive and the last max gap from all. We have this Fen big tree. Okay, we need to learn this particular stuff to maintain the maximum gaps. So just give me uh, pen with bi. Let's see what it does. Actually, we need to learn this particular. Yeah, my okay. We can have reset instead of doing the login stuff. So we have the higher value, lower value. If higher is not equal to length gap, what is this remove value? Okay, can place obstacle rightmost. This is how we can get rightmost. Then if obstacle null or zero, x is greater than size, we can itself and then tell x minus obstacle. Okay, tail is greater than true. Otherwise, max gap, which where is coming from max gap. So we are maintaining the max gap, I guess, right? We are maintaining it. And how it happening when we add obstacle, then we have the higher and lower value. Remove the old gap. Okay. So old gap is this much higher minus lower. Okay. Whatever the old gap is, when we think that, you know, yeah, the lower gap we just trying to remove and adding two new gaps, uh, x to lower. Okay. Lower to x meaning, and then x to higher. And once we added this particular gaps, then we add this particular x into it. And this is function for adding gap count dot put gap increase by one. Probably we need some sort of dry run to understand this particular. Okay. Then this is how we are removing gap. The count, if the count is one, remove gap, max gap 0. Otherwise, get first to nearest largest. Okay, this is a little bit uh, added complexity. I guess we will have another way to do this, the human way, I guess. Mm, so yeah, I need to learn this particular new thing, and yeah, then I'll solve this particular question. This particular TLE stuff, and then once I learn the new thing, I'll try to make a video on that. That the simplest way to put it. So yeah, for now, thank you for watching. Okay.